All right, good afternoon, everyone. Welcome to session 3-159, Alive with Activity, when we're going to be talking about tiles and notifications and their relationship also to background tasks, and look at some of the service end of things that make all these features work as well. My name is Craig Brockschmidt, part of the Windows ecosystem team, and I'm also the author of this book, Programming Windows 8 Apps with HTML, CSS, and JavaScript, which I put out last year at last year's Build conference in 2012. So there is a chapter that really covers most of what this talk does. And we just today also released a first preview of the second edition that I'm working on. It doesn't have this particular subject covered that much in the first preview because it's just a handful of chapters. But watch for that coming out here probably by the end of the year we'll have that book done. So what we'll be talking about, this notion of alive with activity, you've all seen the start screen, and we'll take a look at that again in a little bit, just to remind ourselves of the visuals that the user experiences with this notion. What we're trying to make sure we do is how do our apps really keep themselves connected at many different times and really communicating valuable information to the user through things like the start screen and notifications and other methods. We'll look at the way that apps configure these updates. We'll then look at the role of background tasks a little later on, and we'll also spend probably about half of the session looking at the service side of things, both how you write services for periodic updates as well as push notifications, and the services that Azure Mobile Services will give you in these things as well. All of this is to answer this one question. This is the big question we're trying to answer with everything I'm talking about. We want to create this connectedness and the sense of aliveness where start screens have updates moving and there's data coming in that's being transmitted and communicated to the user in some valuable way. But we don't want to have apps running all the time in order to do that. And now, in an ideal world where, let's say, broadband was infinitely fast and battery life was infinite, and we all had tiny nuclear reactors in our machines or something like that, then of course we could just have everything running all the time, all the code, infinite memory, no problem, and that would be great. But that's not our reality. Our reality is that batteries do wear out, and so that's the keeping apps running all the time is the main thing that contributes to battery life being short. And so we want to figure out how to make this sense of aliveness happen without those apps running all the time, and that's a lot of what the Windows Runtime APIs allow us to do here. Let me switch over to, actually, this wrong machine, this one here. As you probably saw in the keynote this morning, you've now seen the Windows 8.1 previews start screen, and you'll immediately notice that a few things are different. If you've been familiar with Windows 8.1, you'll know that, with Windows 8 as we shipped it last year, you've seen square tiles and wide tiles. Those were the two choices. Now in Windows 8.1, we have also large tiles, which you see are really double the height of a wide tile. And we also have small tiles, as you can see down here, where things like Internet Explorer that by itself, that app doesn't have a live tile experience, so I've shrunk it down because I want it to be very prominent on my start screen, but I don't want it to take up a lot of space. And you'll see, as you've been familiarizing yourself over the last number of months with the Windows 8 experience, that these tiles are updating in a harmonious and smooth manner. And one of the reasons that, as we'll see, you don't get just free-for-all. We don't have a free-for-all on the start screen where every app can just do whatever it wants. Every app has to align to certain templates and certain designs so that there is a sense of unity across the entire start screen. The apps don't also control when updates happen. You can issue the updates and say, here's the 1 or the 2 or up to 5 updates that I want to cycle through on my tile. But when those exactly happen is controlled by the system, so that there's this overall sense of beauty and harmony and flow and fluidity happening on the start screen. So it's really a notch higher than, of course, just a static start screen, but also if you just had randomness and every app could do whatever it wanted, it would be chaos. So we don't want to have chaos, we don't want to have static, we want to have alive with activity, but in a beautiful and harmonious way. Now, a couple things I want to show you about the start screen if you haven't seen them yet. Notice that we have group headings here, and if you right-click on any tile or tap and hold, you can directly edit those group names right here in the main view of the start screen. And then doing a semantic zoom out gives you easy ability to rearrange the start screen. Something else I want to make you aware of On this particular device, it's a 100% scaling ratio, or 100% scaling for the pixel density. There is a setting now for the start screen where, when you say show more tiles, this has been here before, but one of the things it does on a machine like this is it actually shrinks all the tiles down a little bit to what is an 80% scale of the 100%. And I mention this because as you're targeting pixel densities and want to make an app that can operate across a machine like this and those nice new small 7-inch devices, the Surface Pro, which runs at a 140% pixel density, and there's other devices that run at a 180. You need to make sure that you're providing scaled graphics for each of those to make sure the app looks its best. The other thing, let me turn on my tiles larger again. The other thing to know is that, again, we have 4 tile sizes now to be aware of. As much as you can, have your app support all 4 tile sizes. We can create a small tile from your square tile, but you should still look at that to make sure the text is coming out well, the graphics are coming out well. And the other thing I should mention, if you haven't seen it yet either, this little arrow down here at the bottom, that goes to the All Apps view. And we had this in Windows 8, but it becomes much more accessible in Windows 8.1. And you'll notice that all the graphics on here are yet another size. These are 30 by 30 graphics that populate this screen, so you want to make sure you pay attention to those as well. So there's really quite a number of graphics to have a really good start screen experience for your app. And I just want to emphasize this again because when a user installs an app, and they go to the store, they install it, and it comes up on the start screen, that's their first experience of it, is your presence on the start screen. And if you have a good tile experience going on, the better first impression you'll make. And as we'll see, one of the new features we have in Windows 8.1 is the ability to configure a live tile in your manifest so you start getting updates even before the app has been run the first time. But we'll come back to that in a little bit. I do just want to show a little bit of, if I can find, I got lots of code running here, so let me find the app for just what Toast notifications look like, because we're also going to do those. This is one sample in the SDK called Scheduled Notifications. I just issued one for 30 seconds from now. I'm also going to go to the store and install an app, and while that's all going in the background, eventually you're going to see these things show up as Toast notifications. In the meantime, I'm going to go to PC settings and show where some of these things are controlled and configured, just so you know where the user is experiencing these. Lock screen is where the user can configure the lock screen. We'll talk a little bit about, there's one notification showing up. We should get the other one soon. That they can configure, as they could in Windows 8, the different lock screen apps that have the ability to show information on the lock screen, the one that gets a detailed status. And if you, I don't know if somebody demoed in the keynote, I didn't watch the whole thing this morning, but the user can also configure a dynamic slideshow going on the start screen now as a background. With Toast notifications as well, down in Search in Apps and Notifications, this is where the user can control whether any notifications show up at all. So like if I'm doing a screen recording, I just shut them all off because I don't want other apps to be popping those up. You can also set what are called quiet hours for when notifications won't appear because you're sleeping and you don't want audio toast to come up. And the user can always control notifications for every different app individually. So this is a good thing to remember, because if you decide to overuse Toast notifications and you're just throwing too much up there at any given time, the user can just go shut it off completely and therefore defeat the whole purpose of having Toast notifications in the first place. So use them wisely, use them to make a better user experience instead of just to throw up noise and whatnot. And by the way, if you check the Windows Store certification requirements, you'll see that you can't put ads and things like Toast, and they'll reject you if you try doing something like that. Just to show the lock screen, so we're familiar with that particular feature of the UI. This is what mine looks like, a little graphic of a photograph of a flower that's about 2 millimeters in size that I took in the Rocky Mountains at one point. But you can see that down here, besides the system-controlled time and date and battery status, I have my calendar is set to my primary detailed view for the lock screen. I have some new emails here with a small logo for the app, plus what we call a badge, which I'll talk about a little bit more. And then also in Windows 8.1, we have an alarms app that can show up here as well. All right. me just get back into this. And the other thing I want to mention, actually no, that comes later. Let me switch back to the deck. And just review a little bit about what we've seen. So, like I said before, all the tiles the tile updates that you send from whatever source it may be, these are actually just pieces of XML that describe what should appear on that tile. But you can't just, again, do anything arbitrary. You have to use something from a predefined template, which keeps, again, that sense of unity and harmony amongst all the different tile updates that are happening. Now, I do want to mention that if you look at your start screen and look at something like the Finance app, you'll see that it has some really interesting graphics going on there, because it just uses an image-only template, and it generates an image on the fly and puts that into its tile update. So you can do quite a bit of flexibility that way, but you just have to go to the extra trouble of creating an image from scratch. When you send an update through whatever means are necessary, you want to always send a square tile update, a wide tile update, and a large tile update as part of the same piece of XML. This is important because one thing I didn't show, let me go back there really quickly. Here on the start screen, once it comes up, did I get the right one? No. On the start screen here, when I right-click or tap and hold one of these tiles, look down here, there's this little command called resize, and this is where the user can control what of the 4 different sizes they want to have displayed on the start screen. If they change it from this large tile, which happens to have a live tile update on it, and they go to the wide tile, well, you can see that there's an update still available for the wide tile. Same thing with the medium tile has its own update as well. They're all a little bit different. You can see that the graphics are actually coming from what the large tile has. But because the user can switch all those at any given time, if you don't provide an update for each tile size when you issue them, and the user switches to a different tile size, you may end up with a tile that doesn't have an active experience going on at all. Okay. So in these templates, you can have text only, you can have image only, you can have combinations of text and images. Some templates provide for multiple images on the same tile, as you could see with that one the large tile that I have. There's things called peak tiles, and this is where, say, take a large or take a wide tile that's about a rectangle so big, and there's an image on that, and then it also in the template describes a chunk of text below it. And when that tile shows up, you'll see that the image will appear first, and then it'll peek up to show the text, and then it'll go back to the image, and it can go back and forth between those. So you get more information in one tile update than would necessarily fit on the default tile size to begin with. So you'll see in some of the tile templates, if you look through the catalog of available sizes, you'll see a wide template, but it's actually showing you that much information. Or some of the large templates can have a peak, and they're looking really big at that point. But that's just what's going on there. One thing to mention about images on tiles is very important, is that there's 2 limitations. One, they have to be under 200K in size, and number 2, they have to be less than 1024 pixels in either dimension. If you exceed that, exceed the size or exceed the pixel dimensions, then that update will not be issued and won't show up on the tile. So this can be a real gotcha if you're trying to write a service or write an app and you're debugging it, and you can't for the life of you figure out why this tile update isn't showing, and you have an image that's 201K. There's your problem. So you have to really be careful about that. Be very choosy then in the image format that you use. If you're doing things like line art, then PNG 32 and GIF formats work really well. If you're doing photographs, PNG 32 tends to get really large, whereas JPEG and PNG 8 end up giving you much smaller file sizes because they're more optimized for photographs. So choice of file format makes a difference to get that size down, and that's always something to be aware of. So just to go over the anatomy of the different kind of parts and elements of tiles that you see. This is just showing a variety of different templates, but what I wanted to point out is down in the lower left-hand corner, you'll see either the logo image of the app, and this is a monochrome, I think it's 32 by 32 pixels or something along those lines. And it's a white image against a transparent background, and that's how we can get it to show up really nicely against whatever branding color you have for your tile. You can also show text there instead of the logo, or you can choose to not show anything. Those are the three options for what we call branding in a particular tile update. What you see over here on the lower right-hand corner is then what's called a badge. And a badge is either a number from 1 to 99, or it's one of a number of predefined glyphs. So like the pause here, or this little notification, or the new mail icon, those are all what we call badges. Those are separate from the rest of the tile updates. And badges can also appear on small logos. So the small logo, the only live tile experience the really small one can have is a badge. But still, it's there and available. And of course, as you've seen, these things do animate themselves and can go back and forth, like I said, with the peak animations. Similarly, Toast notifications also have a variety of templates that you choose from. They're somewhat simpler because you're either really just working with some text or image plus some text. So there's not quite as many variations on there. And then the color that shows up is the color you have specified in your manifest. And then the logo that shows up is also part of your manifest as well. So those are all branding elements. Sometimes people ask, by the way, whether you can get the system colors and have a Toast notification show up as if it came from the system. The answer is absolutely not. And the reason for that is we don't want any app spoofing a system notification to say, hey, you really desperately want to click this. And if it came up in the system color, that would indicate it came from the system. So the app is always branded with its own color in the manifest, and that way the user can really easily identify and know which app that is coming from. And then just to review again on the lock screen, the things I have circled here are those elements that are under app control rather than the system's control. Again, one app gets its most recent tile update text in the detailed status next to the time, and then up to 7 other apps can have badges plus their logo along the bottom. So now how do we make this work? So like I said at the beginning, there are 3 different ways that apps can configure updates. The simplest one is that if the app is running, you can of course issue an update to your tile whenever you want, and you just basically create the piece of XML, send it off, and then it will do its thing. But when you're not running, what can you do? Well, there's 2 different ways that this happens. One is through a periodic update, which is the polling model. And you can either spell poll, P-U-L-L, as if you're pulling an update down from a service, or polling, P-O-L-L, which is you're asking a service periodically for that particular update. In these cases, what the service is doing is it's just returning the XML as if you would have created it locally. It's just doing that on the server, and then we can have Windows will be set up to ask the service anywhere from intervals between a half hour to 1 day, and basically get that XML and issue it then on behalf of the app. So this is one of the key ways in which you don't have to have an app running to get updates, a real good sense of freshness happening on the tiles, because Windows will go out and ask that service as frequently as half an hour to get those things. Now the third method is doing what is called a push notification, and this is where nobody's making a request. There's just some service out there running, typically your service or an Azure mobile service that's been configured for you. And whenever it sees the need to push something down, it packages again up that piece of XML and shoves it through the Windows Notification Service, WNS, which has a particular channel URI, that's what it's called, that ties that URI is tied to a specific user on a specific device, and even a specific tile on that user's device. So it's a very specific identification of where that notification is going to end up. And when the service decides it wants to send it, it'll just push it down, and it'll show up on whichever device is connected to that URI. And we'll see how those things work. Now, the other way you can do this is you can set all this kind of stuff up, especially issue local updates, through a background task. And that's why I bring background tasks into this particular talk, is because that's code that can run on behalf of the app in the background, but there's just quotas on top of how often you can run, how much you can run, how much CPU time you get. There's another talk that I'll reference later that will go into detail about background tasks, but that's an important way if you have a certain background task that's running and detecting certain conditions and you want to update your tile, that's perfectly fine. So you can issue local updates that way. So what makes an update, again, is a piece of XML that comes from predefined templates. And the next 3 slides after this will go into really look at the schema for those XML updates and all the capabilities that you have there. There are these different places on the Windows Developer Center that are the different tile template, toast template, the badge catalog, and toast audio options catalog that go through all the different variations that you can find for what you do there. But more important than that, and actually a little more useful for you, let me switch over to it here, is what's called the, let me find it here, is the tiles sample in the SDK. And specifically, this is one that just lets you play around with doing local updates. But here in scenario 5, if you can read that, it says preview all tile notification templates. Now, right now on the Dev Center, we don't have all the Windows 8.1 templates documented, but this sample does document them. So you'll notice, for example, we have this huge list of different templates. These are all the different tile templates from the square ones. You'll see that like the square tile square 310 by 310 image and text 01, that's the name of the template. And it looks like this. It has an image and it has one piece of text. And what's really powerful about this particular sample is not only that it shows you all of the current tile templates, so here's some of the 150 by 150 squares and so forth, is that when you pick one of these, and then you can come down here and put in an image, and let me find my notes here, and put in a gratuitous image of my kid, which you always have to do as a father, right? You have to put up pictures of your kid. And let me just say this is Liam learning to sit up. He's now 7 and he's now 6.5. So this is quite a while ago. Learning to sit up. And when you say send tile notification, there's 2 things that happen. One, it does go out and issue the update to the tile here. And because I didn't send anything but a square tile update, I need to resize that to medium. Then we should see it happen. So this is a great way to test out and build locally sent notifications. But I can't really scroll down any farther in this app, but if you can see the very bottom of the screen, you'll see the exact XML that was generated and then sent to the tile. So for right now, if you want to work with Windows 8.1 Preview, especially with some of these larger templates, let me find one for you here. A template like this is the way you're going to find out basically how to build the XML. Go here, find a template that you want to use, build out an example of it, and then copy that XML into whatever you need it for. Okay. All right, so definitely go to these catalogs because there's a lot of good stuff there, but then use that sample as well. So regardless of who's going to issue the update, whoever it is, whether it be a service for push notifications, a service for periodic notifications, or your app or your background task, you're just going to build up this XML and issue it through the appropriate APIs. In any of these, you can reference images that are either in your package, that's an ms-appx URI, that are in your app data, which is ms-app data URIs, or anywhere on the web with HTTP or HTTPS. So you can just put it whatever image references you want to, and they will work just fine. Now that said, it is true that if for some reason a tile update comes down and just at that moment you pull the network plug and Windows can't actually get that particular image, then some placeholders will show up. But that's usually not something that takes really exact timing to get that particular scenario to come out right. I do want to mention in the samples there's this library written in C# called the Notification Extensions Library. And the nice thing about it being in C# is that you can take it and recompile it for an ASP.NET website and use it there as well. But what it does is it gives you an object model on top of all these XML templates. So you don't have to be going in there and finding the right tag and replacing things. It just gives you an object model where you can set properties on objects to do exactly that. And it will spit out then the appropriate XML. So it's a really nice tool to have because it cuts down a lot of the errors that you might be making otherwise. Okay, so let's look at the XML. I'm going to start with the badge XML because this is the simplest one. It's simply got the XML header tag, as all XML does, and then it's got one element called badge, a value attribute that is either a number from 1 to 99 or one of these predefined glyph identifiers. And then there's a version number here as well. Now in Windows 8.1 you can put a version 2 here. We really didn't update the schema for badges at all, so typically you'll still just use version 1. But where that becomes a little more interesting is in tile updates, because we have two different sets of templates. Windows 8.1 has one set of template names, Windows 8 has another set of template names. So let me explain a little bit about how this is put together. So again, you have an XML tag at the top. XML is still version 1 itself, so don't version the XML tag or I can guarantee you your tile update will not appear. I tried this the other day by mistake, and guess what? I was pulling my hair out trying, where's my tile updates? Because I versioned XML for some weird reason. But then you have a tile element followed by a visual element, just one visual element in the tile. And then the visual element has one or more binding elements in it. And typically, if you want, as we recommend, if you're sending a square, a wide, and a large tile update at the same time, you're going to have 3 binding elements together. And each binding element then contains some number of children that are image tags and text tags. So this is not HTML, this is just plain XML, so it's not an IMG, it's an IMAGE tag, which then describes where the images come from, what text should appear, and so forth. Now there's a lot of other stuff going on, so let me go through a few details here. So the version number for the visual element is actually very important. If you set this to 2, for Windows 8.1 Preview, then you enable all the Windows 8.1 templates. If you still have this set to 1, then Windows is going to interpret it as a Windows 8 template XML update, and if you then try to include an 8.1 template, it's going to fail. You can specify the language, you can specify a base URI, which will be prepended to any other relative URI in the tile update, so you don't have to type out a long URI every time. Branding is where you can put either the word none, or logo, or I think name. Those are the 3 options. And that gives you the ability to then determine whether or not, like we saw on the start screen, you get the logo, the text, or nothing on that lower left-hand side of the update. Add image query is, if you set this to true, then any request for an image, if Windows finds a remote URI that is HTTP or HTTPS anywhere in this update, it's going to take and add on URI parameters to that URI when it makes the request to the server, which is going to contain the current scaling factor that's in effect. So if it's 100, 140, or 180, that will be there. The current contrast setting for accessibility, and also, I believe, the current language. And that way, the service can then decide if I want to localize text that I'm including in that tile update, you can do that. If I want to use a high contrast image or not, I can do that. Or add a different scaling image, you can do that. So that's what that's for. Now down in the binding, you'll see some of the same kind of stuff. Each binding can have its own branding, can have its own image query determinations, and so forth. And you can even do add image query down on each image level. But you'll see here, template is where you specify the template name. In a version 2 XML update, you're going to put in a Windows 8.1 name here. And you'll notice in that light blue text is where I've put the 150 by 150, or 310 by 310, or 310 by 150, or 70 by 70. Those are the 4 sizes. Well, actually, sorry, there's no bindings for the small tiles, just those other 3. Then this fallback attribute, which you can have, which is optional, that's where you can specify a Windows 8 tile template. And what this allows you to do with a version 2 visual is have the same update work for both Windows 8 clients and Windows 8.1 clients, provided with one caveat that you make sure that any large tile update is the last in the list. Otherwise, Windows 8 will get a little bit confused by it. So make sure you do that. The other little thing here is this content ID string. Now, we didn't really make much use of this before, and actually, I think it's new for Windows 8.1. I'm trying to remember exactly when we introduced it. But if you think about it a little bit, the amount of information you can put on a small tile and a wide tile is significantly less than a large tile. On the example that I'd been showing before, and actually let me go back there really quickly, because I want to uninstall this particular app. You can see that I have basically 3 wide tile updates on I didn't want to do that. 3 wide tile updates, or the equivalent of 3 wide tile updates on this one large tile. And so if I wanted to issue 3 different wide tile updates to cycle through for this app, I also am going to put this same large tile update in each one of those. And so what you want to do is, well, you need to prevent Windows from thinking that it's got 3 large tile updates, which it doesn't because they're all duplicates. So if you put the content ID in, if the content ID between multiple updates is the same for that particular tile size, then Windows won't consider it to be a different update. It won't actually cycle through those. Let me show you a little bit of what that looks like going to the browser. Let me open a new window and just grab a URI for, if I can find it. Okay, here's one URI. Let me get it selected for that update that you're seeing. This is going out to a service I have out on Windows Azure. And here's what's coming back. This is a full tile update that's creating 3 different sizes and 3 different templates. You'll see that I have, here's the Windows 8.1 template name, and then under fallback you have the Windows 8 name. But notice down here that I have a content ID of 1 on the third binding, which is for the large tile. I also have another page or another endpoint on my service that returns a slightly different piece of XML. Now, if I go between these two, you'll see that the square and the wide tile updates at the top are significantly different. They have different images and different text. But the large tile update at the bottom is exactly the same. But because I have this content ID of 1 on there in both cases, and I have content ID of 2 on the wide and the square tile updates, then Windows will consider the square and the wide ones different between these 2 pieces of XML, but it will consider the large tile the same. And so it won't animate the large tile at all. And you can see it's been sitting here static, and if I resize it, though, to actually, I don't have that demo running yet. But you'll see it's only got 1 coming up. But anyway, for right now, I'm going to actually uninstall this app because we need it a little bit later when we talk about configuring these things in the manifest. Okay, so that's the XML schema. Now, the XML toast schema is very similar. You have a lot of the same kind of stuff on it. The toast element itself gives you the ability to specify launch parameters as well as a long or short duration. And there's a place in the Ease of Access Center PC settings that lets you determine what those, what the short duration is. So you can set it from somewhere like between 5 and 25 seconds. And then a toast just has a binding template as well, again with, a binding element with a template in it. It's got some images and some text, and then it also adds this little audio option down at the bottom. So alongside the visual is also an audio element that lets you choose from some number of predefined identifiers, again, for what sound you would like to have, whether or not you would like to have that sound looping when the notification happens. These particular identifiers are all mapped to individual system sounds, so if the user has all sounds turned off on their machine, then they will never hear sounds at all. I normally have that happen, and it confused me for a while when I was trying to write some codes. Like, I'm never hearing audio because I had no system sound set up. So, but if the user has chosen a particular sound scheme, and then you've identified like the default sound here, they will get their default sound, not anything that you specify specifically. So they'll recognize their own sound scheme. You can't customize these. There's only a limited number, and there's so many to choose from, but we didn't want to enable you to download a 3 megabyte MP3 for a toast notification. That just wouldn't be practical. Okay. A quick mention of secondary tiles, because I'm not going to go into detail on these, but I do want to mention a few updates to this in Windows 8.1. Is that, secondary tiles have been around since Windows 8. It lets you, if you allow pinnable content or bookmarks of some kind in your app, then you allow the user to make more entry points to your app on the start screen, which is, again, you're trying to allow more presence, so secondary tiles are a good idea. What changes in Windows 8.1, if I go back to my machine here, let me go over to the secondary tiles sample. And this sample's been updated, but I want to show you what the new pinning flyout looks like. So in Windows 8, basically you provided one image and the user could type in a piece of text, and that's what got pinned to the start screen. Well, you'll notice that in 8.1 you have these little flip view handles here, and that allows me to go through and select what tile size I want, first of all, but then I can select any number of alternate images for that tile if the app has provided them. So this gives you the ability to really, if you're looking at a piece of rich content and you have multiple images in that content, you can provide the user the ability to select any one of those images to use on the pin tile. And so if I select this one, for example, and pin it to start, then you'll see that it's shown up right here. And so that's a secondary tile coming in. All right. Okay. So let's go through just quickly some of the way the APIs work for doing these updates. Issuing from a running app or a background task uses the Windows UI notifications. In that namespace, there's a thing called a tile updater, a badge updater, a tile notifier, and a secondary tile updater object. These are all just individual API entry points to the things that talk to these different parts of your app, to your tile, to your secondary tiles, to the badges on your tiles, and to toasts issued on your behalf. When you want to issue one of these, you build up your XML, you pass that XML to one of these objects, the tile notification, the badge notification, or the toast notification. You get the object back from that, and then you pass it to the updater, and it will issue. It'll make that basically appear as you need to. Scheduled notifications work a little bit differently. You still use the same updater objects, but instead of building a tile or a toast notification, you build a scheduled tile toast, a scheduled tile or a scheduled toast notification object, again using the XML. But here you specify when you want that, when in the future you want that particular tile update to be issued, or when you want that toast to appear. And by the way, with tiles, you can also set an expiration date. So if you know that that particular piece of content is going to be good from this point in time to some other point in time, you can basically make it appear when you want and then disappear when it's appropriate. And then once that's been scheduled, you'll notice that I have added this little box on the side that says the app can go into a suspended state or not be running at all. And because that scheduled notification has gone into a system queue, the system will still issue it at the appropriate time on your behalf without the app having to run at all. And then periodic notifications are very much a similar thing, but instead of giving a piece of XML directly to Windows, you're giving it a URI that it can go out and ask for that particular XML, just like I showed here recently. And for that, you can do that with tiles and badges, not with toast. It's just for tiles and badges. And basically, you call these APIs start periodic update, or this for tiles, you can do start periodic update batch, where you can give it up to 5 URIs for that it'll go out and query all 5 of those and cycle those around in your tile if you've enabled cycling. Now, like I mentioned before, you can, in fact, do this through the manifest now. This is one of the really nice little changes for tiles in Windows 8.1, is that in the manifest, you can set the recurrence as well as a URI. And then that's how it looks in the manifest XML. And so as soon as the app gets installed, not even having to run, then it will start to go out and query. Windows will start that query on your behalf. So let me switch over to this machine again and find Visual Studio with, I got bunches running here. Okay, push and periodic notifications sample. This is a sample that lets you play with periodic notifications as well as push. We'll be looking at this a few times. But this is the one that I just uninstalled before, that had the large tile update. So if we go back to the start screen, you can see it's not there at all. And if you look for, you start searching on push, you'll see that there's nothing there. So this app is not installed. It's not anywhere on the machine. I'm going to build this solution. Actually, sorry, I need to go to the manifest first and come down here and set a half hour. Go grab the URI that I had before and paste that in. I'm going to actually set it to default too. And I'm going to rebuild. And then I'm going to deploy. I'm not running it, I'm just deploying it, which runs the package installer. And so I can go out to the start screen now, and here's that tile that showed up. I'm going to switch that to a large just to see. And pretty soon here, there we go. We have that live tile automatically happening before the app's ever run. So this is a fabulous thing to add. This is something that was a big feature request for 8.1, because otherwise tiles are just kind of dead and static until the user actually runs the app. So with this little simple thing, and you have a periodic notification service already going, you can get that live tile experience happening immediately. Okay. Let's see. Now I'm going to stay on my demo machine here because I want to talk now about how I actually build the services to provide these kinds of updates. Because for periodic updates, you have to have some endpoint that's going to be generating this XML. Now, I have a few of these built already. I have a very simple badge update, one written in PHP called Day of Month Service. And it's basically, let me go show you the code for that. I'm going here into Visual Studio for Web, Visual Studio Express for Web. This is different from the Windows tool. It's what lets you really work with ASP.NET and PHP and other server-side technologies. And this particular service is very simple. It's 2 lines of PHP, which echoes the XML tag and then echoes a badge update with the current day of the month. So that's all it's doing. So you can see that I have no badge on this particular tile right now. If I take this URI and I give it to the sample, oops, let me find it. Oh, I haven't run it yet, right? I think it's running because it's live. And I go to polling for badge updates. I can stick that URI in here right away, do start badge updates, start periodic updates, that is, and pretty soon we should see there's the badge appears. Now, what's really fun with doing this with Visual Studio for Web, and here's the page that we've been calling to generate the XML. I cheated here and just have a bunch of pre-canned XML because I didn't want to write too much code to try to create more dynamic stuff on the fly. But I wanted to show that if you have Visual Studio for Web running on your local host machine, on your local host server, and I'll show you how to set that up in a moment, and then you can run your client app in Visual Studio for Windows. You can basically set breakpoints in both, and then once you hit that service from the tile polling that Windows is going to do, it'll come and hit this kind of a breakpoint right here. So I do have a breakpoint set. I'm going to run this on my local host right now, and because it goes to this page right away, it will, here it is running. You can see, if you can see that, it says HTTP localhost, port 52568, which is one that Visual Studio has assigned. There's my default.cshtml and the XML it's returning. But you'll notice that when I ran that, I hit the breakpoint here. Well, let me take this piece of tile update and go back to this. I'm going to stop periodic updates for a moment and go back to show you that there's no tile update happening on that particular app. I'm going to put the URI in here that's on my local machine, it's running on my local host. I'm going to start periodic updates, and you'll notice that Windows immediately goes out and makes a request to that service, so it hit my breakpoint in my service. And if I had complicated code here, I could step through it and make sure that it was generating the proper XML that I wanted to. But I can just continue from here, and yeah, the app's running fine, it's running happy, and pretty soon we should again see that XML showing up. Windows 8.1 Preview is a little slow, I've noticed, on getting those tile updates. We'll come back to that. Are you there yet? No. Okay. But just to quickly show, if you're not familiar with this idea of a local host, if you go to Windows Control Panel, the desktop one, and Programs and Features, then turn Windows Features on or off if you've ever gone here. You need to turn on this one right here, Internet Information Services. If you just check the top level box, you'll get the most common options. And then you want to go down into Application Development or World Wide Web Services, App Development Features, and make sure whatever you need is checked in here. So if you're doing ASP.NET, you want to make sure the different versions are checked. If you're doing PHP, you need to have the CGI thing checked. Otherwise, once you install PHP on your local host, it won't necessarily work unless CGI is also there. But what this gives you then is that ability to have URIs with just localhost as the domain name, and turns on this ability to debug things in Visual Studio. And in Visual Studio for Windows Store apps, the localhost is not something you can use in a production app, but you can use it when you're debugging on a machine with a developer license. Otherwise, it's blocked. But you can use it for this exact purpose, to go back and forth and create services at the same time as you're writing your app. Now, the other thing I want to mention in this context, for Windows Azure Mobile Services, we're going to look at this for push notifications as well. There's a feature that's been added the last couple months. If you're familiar all with Azure, you may have noticed this little API thing showed up. this is what allows you to create a custom web API endpoint on a mobile service where you can basically just write a little piece of JavaScript that will fulfill the HTTP request coming to it. In this particular case, I've written one called periodic update 1, and the only little thing it responds to is HTTP GET, which is specified here, exports.get. That's how you say respond to an HTTP GET with whatever the results of this little piece of JavaScript are. And you can see here that I'm getting the date, I'm getting the day of the month, I'm creating that same badge update as we had before. So this is an Azure endpoint that I've created in a mobile service. The URI to that is, let me go grab it here. The URI of my mobile service /API / the name of the endpoint called periodic update 1. And let's go to the start screen and see if that tile update, no, there it is finally. But I'm going to clear, I'm going to clear the badge updates. I'm going to go back here, clear that badge update. And you'll see that that badge is now gone, and I'm going to stick in this mobile service endpoint, start the update to that. It should go out and hit the endpoint, run that little piece of JavaScript, and boom, there we have that badge update came right back. Okay. So pretty straightforward to write your services locally, test them locally, and then deploy them when the time comes. So now push notifications have a little bit more going on, if I can get there. Because here, you have to get this thing called a channel URI that I mentioned before. This is a specific URI that identifies the user, the device, and the tile that you're trying to talk to. And then you got to send that URI to whatever web service is going to send the push notification. So this is just some bit of communication between your app and whatever service that you're using to store that channel URI with whatever other qualifiers you need to. When the service is then ready to send something through that channel, it again builds the XML and then does an HTTP post to that channel URI with some authentication tokens that you get through the Windows Store, and that will connect that toast or tile or badge notification to the particular app that's running. If you have a running app, you can receive push notifications directly through this push notification channel.push notification received event. And a background task also has the ability to trigger on the receipt of a push notification to the app it's associated with, and so it can handle that directly if it wants to. This is so if you want to handle push notifications directly, you can intercept them before Windows does anything with them. But if you don't intercept them and you have XML there, then Windows will just take that and update your tile for you on your behalf. So you don't have to write these event handlers or background tasks to use push notifications. Let me go back to the machine over here just so we can see. I want to show you where you go find this particular information that you need. So on your Windows Store, when you have your different apps listed, if you go into one of those particular apps, and this is one that I set up for the push and periodic notifications sample. I just created a project in the store. I'm not actually going to ship this thing. It wouldn't pass store certification clearly. But down here you'll see if you have an existing WNS solution and blah, 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 visit the live services site. So you click on that, and this takes you into push notifications and Live Connect services, and it says if your app uses WNS for push notifications, you want this stuff here, authenticating your service. There's this package security identifier and a client secret. These are the things that your service has to have in order to authenticate with WNS in order to send anything as a push notification. So there's kind of some steps you got to go through to get this information, but once you have it, then you can write your push notification service. So what that looks like on the server side, on the same sample service, and this is one that I have in my current book that's out in its first edition, is I have two different things. I have one is this page receiveURI.aspx, which is a really brain-dead database receipt function. It basically stores one item into a text file. You can imagine doing something fancier with a real database, but just at least shows how to write the endpoint. So that's all that this one does, and when I take the URI to this, for example, let me grab it on my local host here. Here it is. So receive URI to ASPX, I'm going to go back to the push notification sample. Scenario 1 says registering a notification channel. When I do that, this button down here, it's going to do the API to request a channel URI, and then it's going to post it to whatever URI I put in here of my service. And when that happens, it should have hit a breakpoint, but it didn't seem to. Actually, let me restart it here. Oh, there it hit it. So there's the breakpoint, and I can walk through it if I wanted to debug that particular code locally and then before I deployed it. But basically that just wrote this little text file out here. Let me zoom that in so you can see what a channel URI looks like. So you can see it's bn1.notifywindows.com with this really long, ugly token, and then a username and some other identifiers tacked on at the end of it. So that's a channel URI. That's what I sent to my service. And when I want to then send a push notification, something has to trigger that. Now, in this particular example, I just made another page on this same server called send badge to WNS. And what it's going to do whenever somebody visits that particular page is it's going to load up that channel data, get that URI, and then it's going to build some XML. Here's the XML right here, a badge with an alert glyph. Here's that stuff I showed you before, the client secret and the SID. Oh, there's my toast for my alarm to say, hey, you got 10 minutes to finish up. And then it's going to basically use this function here, which comes straight out of the documentation, which is just how you do an HTTP post to a WNS channel URI. We don't need to go into detail there, but that's the basic mechanics of it at least. So if I go to that, let me clear the badge off of that for a moment. I'm going to clear the badge off. So I do have a notification channel registered for this particular app. There's no badge there. And I'll go to, let's see, go to here. And I'll do, I want to do the localhost one. So that's where the URI is. Let me grab that, paste it in here, visit that site, and it will hit my breakpoint. It'll go through and should respond, taking its sweet time. Generally speaking, it will show up here, but there's kind of a lot of work, and what I really wanted to contrast this with is how to do the same thing with Azure Mobile Services. Let me switch back to the deck for just a moment and say what Azure Mobile Services does for you, as well as two of our partners that are here at Build, and I encourage you to go try their stuff out, Urban Airship and Push.io, that also provide similar kinds of services, is that the necessity to manage a bunch of channel URIs in your service, to keep them straight between which users are associated with them, when you need to send particular push notifications to which channel URI, that can get very complicated very quickly. So all of these different solutions are giving you a better and easier way to manage this kind of stuff and to decide when I want to send a push notification, how do I build this stuff up. So in Azure Mobile Services, for example, if you created some data, the data endpoints in your mobile service, then basically you have some really easy ways to write the channel URIs. And let me switch to Visual Studio, which is this one. Is that right? Yeah. This is basically what it looks like. So instead of doing a bunch of work manually, you create a mobile service client that's, here's the URI for it and an authentication token I have. The next lines down here creates a push notification channel. And this little save channel function that I'm calling here, if I go down to that, basically it's getting a table from the mobile service, writing a record into it, and that's it. It's as easy as that. You've just now written a record into the database. And on the server side, the mobile service can do whatever else it wants. You have a JavaScript piece of code that you can attach to that insertion and add whatever data or modify it in any way you want. And then to actually send a push notification, I have another table in this mobile service called Messages. And if I go back over now to the mobile services itself, let me go back to the mobile service, and here's the data. And I go to the Messages table, and I go to the script. You'll see that on insertion, what this is set up to do is basically it reads the channel URIs that it's received from the table. It builds, in this case, it has some helpers to build the individual sizes of templates. and populate them with particular data, in this case the message. So just to show you that in action, let me run this app first. Hit my endpoint again. Oh, that's a periodic update happening. Let me go to the start screen. Here you see the default tile for that particular app. It doesn't have any kind of notification on it. Let me clear that out. And if I write a message like hello build 2013, that should write it in, and sooner or later we should see that push notification show up. So that just went from here out to my Azure mobile service, through WNS, through that channel back to this machine to give that push notification as an update. So very, very powerful stuff. There's a lot you can do. I encourage you to see session 116, and that should be 3-116. We didn't get the number updated in this deck. For more demos, Nick Harris will be walking through a lot of stuff. He's the primary evangelist for Azure Mobile Services, so he's the expert on these things. There's also a series of blog posts I did called Alive with Activity on the Windows 8 developer blog. That's the bit.ly link you have here, where I go into more detail about these things as well. So let me just quickly go through the little bit about background tasks, because I know I'm a little short on time. In fact, I have about 6 minutes left. Just to show you what those things look like. Again, there's another session on background tasks where you can go into more details about these things. The primary thing that you're looking at here is there's a thing called a maintenance task, which is really useful for renewing push notification channels on a periodic basis. By default, push notification channel URIs are good for 30 days. Well, if your user doesn't run the app within those 30 days, and normally you'll renew this channel when you run the app again, if they don't run that app every 30 days, then you can have your live tile turn off. So it's a really good idea, and as I show in this case, like maybe every 10 days or so, to have this little background task run, which will only take a few milliseconds at most, get a new channel URI, and basically do the same kind of stuff that you would normally do from your running app to register it with your service and make sure that channel URI is up to date. And that way you don't have to have the user run the app. Basically, the way background tasks work is you get this thing called the background task builder. You build a trigger object of some kind with its appropriate properties, and then you add conditions like internet available, and then you register that background task. And the way a background task itself is structured in C#, here's an example of that, where you basically just write a class that derives from the iBackgroundTask interface. It has one method called run, and whatever you put in there is whatever you want to have happen when that background task gets run. And so in here I just have this hypothetical function called renew all async, which would go through all the channel URIs I know about, renew them, and send them to my service. So and that would be code that you would already have written in your app. So you can just bring that into your background task as well. Another case for using background tasks, well, here's how you do the same thing in JavaScript with a web worker, a big piece of JavaScript that runs as a web worker. Pretty much the same kind of stuff. This is what gets run when the background task is invoked. And you would, again, use something like a renew all async method to clear things up there. If you're doing background tasks in JavaScript, by the way, you want to make sure that you always have a way to close it using the web worker's close function. Otherwise, you can leak memory. So just be aware of that. Okay. The last little thing I want to mention here is raw notifications. Everything we've talked about so far is about XML notifications, but sometimes you can have, and if you want to, you can have a service that sends down any kind of information it wants to. Just whatever binary information, whatever structures you want, and that's what's called a raw notification. This only works for push. It doesn't work for periodic or other update methods, but for push notifications, you can have the service just send in whatever package of data you want. So like an email program could have a bunch of different headers and calendar updates and things like that all in one push notification. Because Windows doesn't know what to do with this data, it'll just ignore raw notifications if you send them. But if you create something like you can receive these in a running app if you want. There's a raw notification sample where you can see this demonstrated. You can receive them in the running app, or you can create this thing called a push notification trigger as a background task, and then have that task handle the raw notification, parse out whatever data it wants, and then issue local updates to the tile, issue toasts, issue badges, whatever you want to do in response to that raw data. So it would look something like this. Here's just an example of, again, a background task written in C# that is getting the local app data and taking the this little thing at the bottom here, notification.content. That's the actual data that came down through the raw notification. And then I'm just storing that in app data here, but you could do really anything you wanted with it. So in a quick summary now, so we're just about done with our hour. I just have this slide for your reference. You can take a photograph of it now, as lots of people are, or refer to the slides later on the Build Windows website, of just the different options you have for the different kinds of activity for your tiles, your toasts, your badges, and raw notifications, and which delivery mechanism applies to that. These are the other, I've mentioned the 116 talk that you should go to if you're interested in mobile services. I also recommend 3-071, which is the talk about how to make websites have live tiles and have this Alive with Activity experience, which is something we're introducing with Internet Explorer 11. And then again, 3-108 is the one that covers background tasks. So lots of samples on this. I've shown some of these samples here today just briefly, but really I'd love to make a plug about the samples because there's like 95% API coverage in the samples. If you haven't used the samples in your app development, learn how to do it. Take half a day, download the whole package, look through them all, just run a bunch of them to see what's there, because most of the time you will find the exact piece of code you need to do a particular kind of feature. So if you want to do something with secondary tiles, well, there's a scenario in the sample that shows how to do that. And you can basically just plagiarize that code to your heart's content and be very productive that way. Really learning the samples is one of the most productive things you can do as a developer. Just because there's so much available in there. Unlike other SDKs we've had in the past, this one really has a lot of great stuff in it. And with that, here's session evaluation, which I'll hold up. And I hit 26 seconds left, but I'm happy to answer a few questions. If you can, please step to the microphones on the side, and I will be going over to the apps and presentation area over in the great room after this talk, so you can follow me over there. It'll take a few questions first. Yes?
I have two quick questions. Has the size of the queue for notifications on secondary tiles changed?
No, it's still 5. Yeah.
If the user selects or clicks on the tile and they're in one of the notifications, is there a way now to know which one was visible at the time?
I don't believe we've added that yet.
Okay.
It'd be good, but not as far as I know. Any other questions so far? Yeah, over here. Yeah, go ahead.
You mentioned that you can have a background task to renew the channel.
Yes.
And if the app is not alive for 30 days. What is the guidance? I mean, I've been generally reluctant to add a background task for a lightweight app, but I did run into that situation where the notification does not appear because the channel has expired.
Yeah, so you're basically asking whether or not a background task is a heavyweight kind of thing. Is that sort of the gist of the question?
The user can control how many background tasks can run, and there's some quota limitations as well. So so this is, I mean, I don't consider this as an important app. It's a silly app that shows me my Azure bill as a live update, right? And I can't expect my user to run a background task just for that.
Yeah, you have to really weigh that against, is it good for the user experience? Is it really valuable for the user experience? Because they will be asked for their consent to let this app run in the background, right? And so if they look at it and say, what's the value there? Do I really want it? But they might, they can always say no. And really, background tasks themselves, when you compile that, like if you're in C#, it's maybe a 50K DLL or something like that. And it runs for a very short amount of time, so you're really not introducing much overhead. It can feel like a heavyweight option, but really they are quite lightweight. So don't hesitate and give the user the choice, I think, is really the best way to think about it, if it works good for your user experience. Yeah. I have any others? Yeah, right here.
Yeah, so for periodic updates, half hour can be a long time in some situations.
Yes.
Especially for testing, is there a way that users can set that frequency to happen more often on particular apps?
Yeah, no, the periodic notifications is just a half an hour. That's the minimum. But for testing purposes, if you stop the notification and then redo it again, and like the sample does this, when you can stop, there's a stop button, and then you start it, Windows will immediately get a new update. So as soon as you call that API, it will go out and get the first one. So you don't have to wait a half hour for the first one to show up. And then if you stop it and restart it, it'll go out and get it again. So you can do that for testing, but the user can't extend it, no.
So in general, anything that we need to update more frequently than that should look to like a push.
You should look to push notifications if you need more frequency, yes. Yeah. Okay, one more and then we'll break.
So I had a question about raw notification. When you said
Yeah.
raw notification, user doesn't get any sort of feedback on his device, does he?
That's right. So raw notification can come down, and if
Under the hood goes to the app.
yeah, it goes to some piece of app code. It has to go to app code, and that app can choose whether or not to issue a notification.
The second question I had was that with respect to the background task, how much code you can have in the presumably at some point the system will kick you out.
Yeah, there are quotas on it of how much clocks. It's like 5 seconds of CPU time every 15 minutes is the system limit.
But you get some event that says that you have to terminate now or something like that?
I don't know. You should go to the background task, ask that one.
Thank you very much.
Okay. Well, thank you all, and enjoy the rest of the conference.